Alright, so we have this equation. So this question 14 is a typical multiple choice question. Okay, multiple choice idea question. And it's just a practice of how do you determine the limiting reagent. Okay, so they say there, you have hydrogen gas reacts with oxygen gas to give you water. And then there's 3 questions. You must determine, or you must write down a balanced equation. Then you must determine the limiting reagent. And then you must determine how much mole of gas you have left at the end. Sorry, ma'am, can you quickly check outside? All right. From Ghana, please. And please, you should not become a teacher one day. Eh? You will get in so much trouble so quickly. All right. So, you first write down your mole ratio is 2 to 1 gives me 2. And remember, that is your recipe. So, it's not what you have. It's not what you start with. That is your recipe. They tell you start with 4 moles of this, 3 moles of this, and you should know that you always have 0 moles of this. So that is your mole ratio, beginning, change, end. Okay? You can't just say I'm going to use all of this and I'm going to use all of that. You must determine the limiting reagent. So I'm going to do this on the right-hand side. Oh. Okay. Right, so sukkel aan my. Oh. All right. So, limiting reagent is 2H versus oxygens. Okay, so mole ratio is 2 to 1. Okay, but we don't have 2, we have 4. So you write down 4, you say, right, how much of oxygen will I need then? Okay, so what do you do from there to there? You divide by 2. Same thing there. You divide by 2, so you get 2. Then you ask yourself, all right, I need 2. How much do I have? I have 3. So do I have enough? Yes, I have enough. So then that one is the one that is in excess, and this one is my limiting reagent. What do I know about the one that is the limiting reagent? I use all of it to have 0 at the end. Sorry, I want to highlight that. This is my limiting reagent. I use all of that to have 0. And the other one, I use what I calculated. I'm going to use 2, so I have 1 left at the end. All right, and then you're going to use your mole ratio to determine how much product you will need, you will get. So the mole ratio is 2 to 2. So if I use 4, how much will I get there? 4. Plus 4. So 0 plus 4 gives me 4. Okay. And what is my mole at the end? It's 1 plus 4. So I have your mole of gas at the end is 5 moles. Anyone? Any question? Nothing. Okay, question 14b. What's wrong? Okay, so they tell you have sulfur dioxide that reacts with oxygen and that gives you sulfur trioxide. Declan, is this equation, this is B, ne? Is this equation balanced? So what are you going to do? Yes, you can go, Boki. dioxide, this one. Yes. Okay, so we have a 2 there, a 1 gives you 2. Okay, so that is my mole ratio, that is my recipe. So I should have my beginning, change, end. What I can write down immediately is that I have 0 of that to start with. Bokkie, in the question, how much sulfur dioxide did they say do we have? In the question? 2. And oxygen? Also 2. Okay, now I think it's easy to see which one is the limiting reagent, but let's just calculate it. So 2 sulfur dioxides versus oxygen. So it's 2 to 1. But I don't, well, I do have 2 actually. But so that's why mole ratio is 2 to 1. How much do I have? I have 2. So how much will I need of the oxygen? I will need 1. Okay? I'm just going to show this again. My mole ratio is 2 to 1. 2 to 1. How much do I have? I have 2. So how much of the oxygen will I need? If the mole ratio is 2 to 1, I'm going to need 1. But how much oxygen do I have? I have 2 of it. So I have 2, so I have more than enough. So this one is the one that is in excess, and this one is my limiting reagent. Okay, so my one, that is my limiting reagent, I'm going to use all of it to have 0 at the end. And the other one that is in excess, I'm going to use what I've calculated. I saw I'm going to use 1. So I'm going to subtract 1. Okay, then you use your limiting reagent to determine how much products you will get. The mole ratio is 2 to 2. So if I use 2, how much will I gain? 2. So 0 plus 2 gives you 2. So your mole gas at the end is 1 plus 2 gives you 3. Okay, any questions? Okay, the next one I can't remember at the top of my head. I think it's ammonia plus oxygen gives you nitrogen monoxide and water. Okay, right, Siamo, is this balanced? What do you need to do? Hang on. You want to call someone?
For the second one, call it.
May I have?
There by oxygen, I'm going to put a in front of it. Yes. Ow.
It's not right.
But it is there.
Of water. I'm not sure. Isn't it 3? Or in front of the nitrogen?
Bogey?
What would the H2O?
Let's check quickly. 2, 2. 6, 6. 6 oxygens. 2 plus 3 gives you 5 oxygens. Okay, this is going to take you forever, I promise. So, when you get, okay, so this is a cheat that I will teach you again in grade 12. But when you get that something reacts with oxygen and you get water as a product. Okay, so if there's oxygen on the left hand side and a water on the right hand side, and you balanced and you can't get any further, then you check. Is there an uneven number in front of water? Yes, there's an uneven number. Then it means you're going to have to multiply everything times 2. Okay, so I'm going to scratch this out for a moment. So this is going to become a 4. This is going to become a 4. This becomes a 6. Okay, so I said, how did I know I'm supposed to do that? There's oxygen on the left-hand side, water on the right-hand side, and there was an uneven number in front of water. Then you multiply straight through by 2. Okay, so we have checked here. 4, 4. 12, 12. On the left-hand side so far, I have 2 oxygens. On the right-hand side, I have 4 plus 6 gives me 10 oxygens. How can I make that 2 a 10? 5 in front of it. Easy peasy. Alright, so this mole ratio is 4 to 5, gives me 4 to 6, and I put it there. That is my mole ratio, it's my recipe. So I have mole, beginning, change, end. Okay, and I know I start with a 0 of this and 0 of that. And we'll see, what did they say? What do I start with ammonia and oxygen in the question? Yes, that's my question.
It's 10, 10.
Okay, 10 and 10. Right, so we can't say we're going to use 10, use 10. Okay, so let's see which one is the limiting reagent. So we have 4 ammonia versus 5 oxygens. So the mole ratio is 4 to 5. All right, so I don't have 4, I have 10. So I say 10, and then how much will I need? Okay, I'm going to zoom in on the right hand side a bit. So from here to here, what do? You say divide by 4 times 5. Kumo?
It's 9.
Where's Botsepo? Sorry?
Ma'am? Oh, yeah.
What does that mean? Kiaka?
It's 9. 12,5. Ma'am, can I take 12,5, please?
All right. So, you need 12.5 oxygens. How many oxygens do you have? 10. 10. So, do you have enough? No, you do not have enough. So, it means oxygen is your limiting reagent, and ammonia is the one that is in excess. Because from the oxygen, you need 12.5, you don't have, you only have 10. Okay, so now this one is my limiting reagent, which means I'm going to use all of it to get 0 at the end. Right, now how much am I going to delete here, Kumo? What did Mama say? You can't say minus 10. You just said this one is the one that is in excess, meaning you have things left over at the end. I don't want to ask you. No, what do you say minus 4? You can't say 10 minus 12.5. Like you want to go bake cupcakes. The recipe says you need 4 eggs. You have 1 egg. How are you going to use 4 eggs if you only have 1 egg?
8 minus 10.
Kumo! What's the difference? No. Okay, Boki, your turn. Yes, why? Because Boki told you to. Boki, why is it 8? Yes. I've said this every time, but you guys don't listen when I speak. I say, your limiting reagent determines 2 things. You're going to use all of it, number 1. And it determines how much you will use, how much you will get. So now you're going to use your mole ratio again. You say, right, this mole ratio is 5:4. But I don't have 5, I am going to use 10. So how much will I delete there? How do you go from 5 to 4? Divide by 5 times 4. So 10 divided by 5 gives you, Kumo, times 4? 8. So minus 8. All right. So if you didn't know that, did you make a note now for yourself? Mama, I'm going to throw you something. Right. Okay, then I'm saying this again. The limiting reagent determines how much you will use and it determines how much you will gain. Okay, so let's check here. Are you ready? Yes, ma'am. Okay, this mole ratio is 5:4. But you don't have 5, you use 10. How much will you get there? What do you do from there to there? Say again? Yes, plus 8. All right, Princess, yours is the next one. This mole ratio is 5:6. So if you're going to use 10, how much will you get there? I want to know, Chabu, how do you get to 12? Yes? How did you get to 12? Perfect. All right. So then the mole that you have at the end, the mole of the gas, is 2 plus 8 plus 12, and that gives you 22 moles. Bongani. It was your question, Princess. It wasn't a difficult question. Chabu, you didn't even know why it was 12. There you go. All right. Any questions? Something I must repeat. Yes. Okay, can we just mark the homework?
Oh, I thought you were done.
No, you still had another question.
Yes.
Yes. You had question 15. Okay. At question 15, they say there that you have hydrogen gas and nitrogen gas and then ammonia. John, would you just read the question out loud, please? Okay, out loud. I want to hear. Shh. Yeah? What? You were right. You said hydrogen and nitrogen. Perfect.
And then they said
And? All right.
If 25 tons of nitrogen gas reacts with 5 tons of hydrogen gas, calculate the mass of ammonia that will form.
Perfect. All right. So that is what they asked. I wrote down an equation because it's hydrogen gas that reacts with nitrogen gas to give you ammonia. Tawana, is this equation balanced? What do we need to do? Good. So the mole ratio is 3 to 1 gives you 2. Alright, so that is your mole ratio. Then we have beginning, change, end. And you know you can always start with 0 of your products. Mama, are you allowed? No, Mama. Are you allowed to fill in your grams in your table? No, what should you do? Yeah, but what should you do? Not why are you not allowed to? What should you do? Not why, what? Oh, you guys are taking too long. We still have another lesson. Tippy, so what should we do? Nee. We don't have volume here. Kumo? You have to convert it into moles. Yeah, easy as that. Alright. Now you get a mark for writing down this mole formula. Alright. So I want to see that formula. You don't have to write it each time. You get it marked once. Then we want the mole of the hydrogen. The mass is 5 grams. That is what they gave us. Bongani, what is the molar mass of hydrogen? Hydrogen gas. As jy so toe praat ek Afrikaans, né? So klaar. Nee, ek kan sien hulle spot. Goed, so stikstofgas se massa is 25 gram. Leakwe? Ja. Nee, as jy gaan so toe praat, dan praat ek Afrikaans. Dis die reël. Stikstofgas se molare massa. 7? 7? Sy atoomgetal is 7. Hoe het jy gekom by 28? Say again? No, how do you get to 24? Wacht, ek gaan van daar uitwerken. Kan ek altyd op die James vir hoor? Ja. Elke oggend vir my. Ja. Dankie. Okay, dankie. So stikstof is 14 en daar's 2 stikstowwe, so dis 28. Okay. So Declan, as jy dit uitwerk, wat kry jy? Hey. Sê jy terwyl jy Afrikaans praat? Jy het nou net gesê, "Askies juffrou." Vat jou sakrekenaar. Declan, vat jou sakrekenaar en bereken. Who's your Afrikaans teacher?
Ma'am Andrea.
Sorry, van de
8928. Okay, Bokkie, kan jy sê dat ek dadelik gaan sê minus 2.5 minus 0.8 bla 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 bla. Wat moet jy bepaal? Okay, jou limiting reagent, jou beperkende reaktant. You guys, if you speak Sotho, I speak Afrikaans. Because you are excluding me. I don't know what you are saying. It's rude. Say again? You're not supposed to hit. Physically or emotionally. Okay, right. So we want to determine the limiting reagent. So the ratio is 3:1, but I don't have 3, I have 2.5. So I want to check how much nitrogen do I need. Tiamo, what do you need to do from here to here? Okay, so do that. Okay, so now you check. That is how much you need. How much do I have is 0.8928. So do I have enough, Mosi?
Yes.
Yes, I have enough. So that one is the one that is in excess. And this one is my limiting reagent. But Sepu, what is the 2 things I know from my limiting reagent? Or of my limiting reagent? You want to ask something? Huh?
Ma'am, can you just repeat the question?
What's the 2 things that you know regarding your limiting reagent?
I think we use all of it
Yes, and?
and we determine how much you can use and gain.
Yes, perfect. Thank you for making a note while I give tips. Okay, right. So, the limiting reagent determines how much you will use and how much you will gain. Okay, so here we're going to say minus 0.8333333, and that gives you 0.06. No. Yes? No. 5. What does it give you? Ja, je gaat ik weer aan Afrikaans weer. Can I hear when I don't understand? Yes, Sponkani. I can hear. 595. Oeskies, 595. Kijk, hier in die molverhouding, kom op, is 3 tot 2. Maar ek het nie 3 en ek het 2.5. So, hoeveel gaan ek daar kry? Hulle maak my ook die mekaar. What's that? Niet die nie. Dit is dus 1,666666666. It's not your final answer. Right, so I just want to say this again. How did we go from there to there? You said divide by 3 times 2. So the same there. From there to there, divide by 3 times 2. Remember, this is not your final answer, so you do not round off just yet. Alright, the question was, what is the mass of ammonia? We now have the mole of ammonia. Okay? So just to save space, I'm going to work next to one another. In a test, please write underneath one another. So we have for ammonia, that's what I'm looking at now. Mole is mass over molar mass. The mole is 1.666666 repetitively. We want the mass. Friends, say, what is the molar mass for ammonia? D. Yeah. I. Okay, nou wil ek 'n moeilike vraag vra. Is it 17 or is it 2 times 17, 34?
17.
Well done. Okay. Princess, what do you get for the mass? Nie 71, nie 17.
What you say, Mama?
And the unit? Correct. Yeah. All right. So, next concept, because I think that was your homework, ne? Okay, going. Thank you. Dis omdat jy die hele tyd praat tussenin. Wat sê jy? Blaming. Jy kan, maar ek gaan 'n nuwe werk verduidelik. Ek sal opvang, juffrou. Okay. Right. So now we're going to get to another concept, that is percentage purity. Percentage purity. Alright, so percentage purity has to do with the following. Okay, now you guys didn't see me yesterday, but yesterday I wore a green jacket. Why is it filming outside of class? I wore a green jacket, but we were busy diluting some acids, and some of the acid got on my jacket, and my jacket is not, or my whole jacket is not green anymore. It is now blue purple. Okay, so no, it's not nice. It is done. No. Alright, so I had a green jacket. It reacted with hydrochloric acid, and now it is purple. Purple blue. Say again? Iodine. Starch will not help. So what happened is the hydrochloric acid. What does green consist of? What colors? Yellow and blue. So what happened is the hydrochloric acid reacted with the yellow in my jacket. It didn't react with the blue. It reacted only with the yellow, and then I have blue left. Okay. Now, so if I want to check what is the percentage of pure yellow in my jacket, the color, then I can use this reaction, because I know how much I had of the green. I know how much hydrochloric acid I used. So if I get how much blue is left over, I know how much was yellow, right?
Yes.
That which is not blue is yellow. Now the same thing in science. Let's say I have chalk. Do you still have a teacher that works with chalk?
Yes.
Which one? Well, okay. All right. So, but you all know what chalk looks like, right? Chalk is actually, it consists of calcium carbonate. Mainly calcium carbonate, but there's a few other things in there as well. It depends how soft you want the chalk. So chalk has in it calcium carbonate, but it also has a bit of clay in it. So it depends how soft the chalk writes. It also has a bit of coloring in it. Okay, because you get white chalk and yellow chalk and pink and blah, 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 blah. All right, there's other things in there as well. So if I take this chalk and I dissolve it, I add it to hydrochloric acid, it will give me calcium chloride and water and carbon dioxide gas. Okay, that is the calcium carbonate. But now I said I added chalk to it, or it was not actually calcium carbonate, it was actually chalk. Then there will also be a bit of impurities. Things that are not supposed to be there. So you'll get a bit of slime, or you'll get like a yellow powder that forms, or it depends what you have. Okay, so you'll get also impurities. So we want to know, all right, of this chalk, how much was calcium carbonate and how much was the filth, the impurities, the extra stuff. That's what we're going to determine now. Okay, right, so it says there, sometimes compounds have been oxidized. Oxidized is just a fancy word for saying that it rusts. You've all seen rust before, ne? Things don't actually rust here in Paris. Where I come from, it rusts in a day. At the ocean, things rust quick. Here, it takes 2 years, 3 years. Right, so oxidized means it rusts, or things are mixed with impurities or something like that. So in this lab at the back there, with the chemicals, if something is left open, it will oxidize. So it's not the pure thing anymore, it's reacting with oxygen. Or let's say I wanted a bit of, I don't know if she left the outside now. Here is a bit of the base, it's the powder. Okay? And I left some of it on the table and I just scratch it. Because I want to save it in here. And then I see, okay, but now it's not pure sodium hydroxide anymore, because now there's a bit of dust particles and maybe pencil particles and whatever in here. So it's impurities in this, not just pure anymore. All right. Then they say there, one of the methods of determining the purity of a sample is to add a chemical of certain mass of the sample, which then reacts only with the pure substance. Then the mass of one of the products formed will be determined. Okay? So I explained this already. I'm going to explain this again. So what we do then is we say, okay, let's say I have chalk and I add hydrochloric acid to that chalk. I know the hydrochloric acid will only react with the calcium carbonate. It's not going to react with the rest. And then I can say I'm going to go measure off that salt. I'm going to measure off the mass of the gas. And then I can say, right, how much from there to there, the mole ratio, how much calcium carbonate did I actually have? All right, so that is what they explain there, but I'll explain it again in this example. Then the tip says work backwards. I'm going to explain that tip in the example just now. Then that formula there is not on your data sheet. The same as on the previous page, not on your data sheet. So you don't have to rewrite it exactly like it is. You must just use it, apply it. What do we have in there? Percentage purity is the pure substance over the impure substance, or the small value over the bigger value, times 100. Okay, now they say there, the first example. A 5-gram sample of seashells is heated at 100 degrees Celsius and decomposes completely into carbon dioxide and burnt lime. Okay, all the carbon dioxide produced is collected and has a mass of that calculated percentage calcium carbonate in the seashells. What do we always start with? Balanced equation. Okay, you have no idea what you're going to do, but you're going to write a balanced equation. So we start with that. So write calcium carbonate is heated up, and they tell you you're going to get carbon dioxide and burnt lime. I think Jabu, we're with you. Jabu. Jabu. Mm-hmm.
Is it the same as calcium dioxide?
No. Google? Perfect. Calcium carbonate. Calcium carbonate is a white powder. I showed it to you. Say again? What did I say? Sorry. Calcium oxide is a white powder. Calcium carbonate is also a white powder, and carbon dioxide is a gas. Yes, Mama? Calcium oxide. And Tawana, is this balanced? What are you going to do? No, Bongani's airtime is finished.
Bongani's work is finished, man.
His airtime. We can't call him anymore. Battery flat. Yeah? You get it. It is already balanced. Okay, right. Now let's see. They say a 5-gram sample of seashells is heated and it decomposes into the following. And then they ask calculate the percentage of calcium carbonate in there. So this 5 grams sample of seashells is the impure sample. That 5 grams is not 5 grams of calcium carbonate. That 5 grams is seashell and more. Okay, so I'm going to draw a seashell that I missed incredibly from my days in Hermanus. Do you know what an abalone shell looks like? It's not illegal, but it is endangered. I'm going to show you a picture. So this is what it looks like. Okay, just the shell, not the food on the inside. The food on the inside just looks like almost like a patty. Huh? It's endangered, so there's 1 weekend a year where you can harvest this from the ocean. The rest of the time you're not allowed to. It takes 4 years for one abalone to reach maturity. And the people harvest it, so there's we call them poachers. They take them out of the ocean. They sell them to mainly the eastern countries like China. And in China they believe it's an aphrodisiac. You know? Do you know what an aphrodisiac is? No. An aphrodisiac is something that enhances your... No. It arouses you sexually. It arouses you sexually. No, not the shell. The food inside the shell. So the shell is just. So it's like a snail. Sorry there. Okay. Okay. So that's what it looks like. All right. So you see this here. This is so the food there. It they call it an aphrodisiac. So it means they think it's not proven, but they think that it excites you. Okay. So a lot of Eastern countries, they believe in that, and then they buy this, and they buy it a lot, and so much so they'll pay so much for this that no, that is endangered. Yeah. No.
Mama, if you don't get it, forget about it.
Yeah, if you don't get it, it's better. All right. Thank you. So. I just, because I know the bell's going to ring any moment, I just want to say, so they say, you have this shell. Okay, so why did I tell this story? You should know something about South Africa. You should know that this is an endangered species. Why is it an endangered species? Where is it going? We must protect it because we are the only place in the whole world that has abalone. So nowhere else in this whole globe of ours is there abalone. So if this is gone, then it's gone forever. All right. Okay, so this abalone shell, or the shell, they say, this whole shell weighs 5 grams.